Okay, good day. So we will be discussing all about starting marine diesel engines. So motto for today. So marine engineers were created because deck officers need heroes too. Okay, so that's our motto for today. So as marine engineers, we make sure that all the components, especially the components that the deck officers are using, are in optimum uh, capacity, or it can be used properly by the deck officer. So marine engineers were created because deck officers need heroes too. So okay, so let's start our topic, starting marine diesel engines. Okay, so there are different methods on starting the marine diesel engines depending on the size of the engine. So small diesel engines may be started manually. Medium diesel engines may be started by the use of starting motor like electric, hydraulic, or air or pneumatic. And large diesel engines are started by compressed air up to 30 bar pressure. Okay, so this is an example of a small for medium size diesel engines. So this is an example of a starting air motor. So this is a pneumatic starting air motor, pneumatic. So the parts, this is the air starter, and number 2 is the pressure reducing valve. Number 3 is um, the gauge for starting. So this one, the gauge for starting air. 4 is the safety valve. If ever there will be overpressure, the safety valve will open. Number 5 is the solenoid valve. Number 6 is the starting control valve. And the 7 is the start blocking valve. So if ever the starting air motor is disengaged, so you can start the motor. But if it is engaged in the flywheel, then the start blocking valve will activate, preventing the starting of the engine. Okay, this is an example of our pneumatic starting air motor. Okay, the starting air motor. So there is air that will be the one that will help this motor rotate, and there is also another air. So the air in here will push the gear, the pinion gear here. It will push to the right, and since your flywheel is in here, so let's make a simple drawing. So if your flywheel is in here, your flywheel of the engine have gears also. Okay, this is the pinion gear, this one. If this pinion gear is rotating on its own without pushing it to the right, so it will not engage the flywheel, so it will just rotate. So there is a solenoid in here. I think it's in here, the solenoid in here. So the air in here will be the one that will help this starting air motor to rotate, and the solenoid valve here is the one that will push this one to the right, so that this gear, the pinion gear, will move inside the flywheel, and if it rotates, then the flywheel will also rotate. And then after the starting, if the engine is now running, so this pinion gear will go back to the left and disengage the flywheel. So that's how it works. So starting air motor, when air is admitted, the bendix will engage the pinion with the flywheel. So when the engine reaches a set minimum RPM, the air is cut off by and the pinion will disengage. So if the engine will run at its idle RPM or its minimum RPM that it can run on itself, so the starting air motor will disengage its pinion gear. from the flywheel. Okay. Okay, conditions required for air starting. So starting air can only admitted. So this is a different type of starting. So we are done with using starting air motor. So the starting air motor we can use air or pneumatic in this one. We can also use hydraulic starting air motor. So you just pump pressure onto a chamber, and that pressure will be used to run the starting air motor and run the engine. And then we can also use electric. So electric using batteries. So we usually use that on our emergency generators. Okay, another way to start the engine is using the starting air or 30 bar pressure starting air. So starting air can only be admitted when valves are closed and piston moves downwards to the power stroke. On the power stroke. So engines should be able to start in any given position of the crankshaft. So what is the minimum required number of cylinders to make this happen? So the minimum number of cylinders required is for a 4-stroke diesel engine, from example. So power stroke is equals to 180 degrees minus 52. So 4-stroke diesel engine minus 52 is equals to 128 degrees. So 1 power stroke per 2 cycles is 720 degrees for a 4-stroke diesel engine. So the minimum number of cylinder, so 70 divided by 128 is equals to 5.6, or we can round it up to 6 cylinders. So that is the minimum number of cylinders required to start an engine, 6 cylinder for 4-stroke engine and 3 cylinder for a 2-stroke engine, but actually for to have some overlap. So since 3 cylinder is it is most applicable or better to have some overlap, so we can use 4 cylinders for 2-stroke engine. So if you will use engines with lesser cylinders, so it's very hard to start this engine using the starting air 30 bar pressure system. So firing order depends on firing order is the sequence of firing depending on the engine. So for example, if you have a 6-cylinder engine, so if possible, okay, like this one. So first to fire is number 1, and then if it is rotating clockwise, for example, this is one is rotating clockwise, so the next one that will fire will be this one, will turn. So the next odd number that will fire is number 5, and then next is number 3, and the next is number 6, and then 2 and 4. So that is our firing sequence for this type of engine, 6-cylinder 4-stroke engine, 1 5 3 6 2 4. So always there is always a partner for the cylinder. So for example, if you have 6-cylinder engine, so the partner will be 1 and 6. They are the farthest part from the center of the crankshaft. So 1 and 6, so since sila yung nasa dulo, they are the partners. So dapat pantay din sila. Kung naka-top dead center yung isa, naka-top dead center din yung isa. So they are called the running mates. So 5 and 2 are the running mates, and 3 and 4 are the running mates. So this is our 4-stroke diesel engine. So the firing order will be 1 5 3 6 2 4. While for 2-stroke diesel engine, to obtain equal distribution of firing, if this cylinder is rotating clockwise, so we put 1 2 and 3. So this one will be rotating clockwise. So the first one that will fire is number 1, and then next is number 3, and then number 2. So there are every 120 degrees of the crankshaft, there will be a firing. This one also 120 degrees. Okay, So we will continue with the starting air system. The starting air pressure should be between 1.5 megapascal or 15 bars to 30 bars. So that is the minimum requirement. So if the air is less than 15 bars, so the main engine will not start. So it's too the pressure is very small if it's not it is less than 15 bars. So starting air is direct injected into the cylinders through the starting air valves in the cylinder heads. So this was already discussed. We already discussed this in our classroom. Okay, the starting air system. So minimum requirements. So first, minimum requirements, we should have 2 starting air compressors, both on automatic control. We have also 2 starting air bottles or air receivers. So normally 1 compressor and 1 air bottle is in operation, the other one is on standby. So other bottle full and closed as spare parts or as spare. So capacity of air bottles, so for non-reversible engine, it should have the capacity 6 times. So you can start the engine 6 times. But for reversible engine, for especially 2-stroke engines, so the capacity of the air bottles should be used 12 times to start the main engine without the starting air compressor if ever this one is damaged. So the capacity of the air bottles should start the engine, they could start the engine 12 times. And for non-reversible engine like 4-stroke engine with controllable pitch propeller, so with the minimum capacity of our air bottles can start the engine 6 times. Okay, so let's go. Internal starting air system, so we've discussed this already, but this diagram is a simple diagram also, so we can go with this. Okay, from 301, the air will go to number 10, which is a non-return valve. We have an 11 drain valve, so you can drain air in here if ever, or water in here if ever there is water in the system manually. And then it will go on this number 1, the main starting valve. So the air will stay in there. Okay, and then another line, we have 302, which is another starting air or another air supply, going here on this manual valve, and to the number 6, which is a high pressure air filter with an automatic water outlet valve at the bottom. And then number 10 is a non-return valve going to the number 10 air container. After the air container, the air will go here to 08A solenoid valve starting and 08B solenoid valve slow turning. So if you want to start the engine, we can use the starting. If you want to just put the engine on standby every 30 minutes, for example, so you can use starting air slow turning solenoid valve. So this will always help the engine to turn twice every 30 minutes or depending on its setting. Okay, for example, if we want to start the engine, we will activate 08A, which is the solenoid valve starting. Air will be admitted to number 9, which is the blocking valve turning gear. If the turning gear is still engaged, so this will block the starting. Okay, but if the turning gear is already disengaged, so we can start the engine, so we can use this will be activated, and air will go in this side going to the drain. So this will activate, and then the drain for the filter will activate also, drain, and then another air will go on this starting valve, activating this valve, and then the flow from 301 will now enter to the starting air with flame arrestor. So number 2 is the flame arrestor, prevent flame from going back to our system, which will create explosion. And then going to the starting air valve, depending on which starting air valve is on power stroke, so another air will go to the starting air distributor, We have protection here, number 5, which is the bursting disc. If ever there will be overpressure, so the bursting disc will explode or will burst. Okay, so there is a distributor. So depending on the power firing order, so if, for example, if the firing order is 1 first, so the number 1 and starting air valve will be activated, and then if this is on the power stroke, so the air will be admitted to the cylinder with the power stroke, and then we will start the engine. And then when it turns, another cylinder will have its power stroke, so another air will be admitted to that cylinder, and this one on the other cylinders will be closed. So that's how it will start. Okay, so that's how the starting air system works. Okay, the internal starting air system for V engines, for engine up to 12 cylinders starting on one bank, over 12 cylinders starting on both banks. So for a V-type cylinder engine, we have 2 distributor, and then on this side there is a distributor on this side for this cylinder on this side, and another distributor for the engines on this side, since this is a V-type engines. Okay. Okay, we'll go to internal starting air system. So this is the 301. In this part the air enters, and then it will go to number 1 here, to number 2 main starting air valve, and then here to number 3 the starting air valve, enter to the starting air valve, and then another one goes to, another air goes to the here the distributor, and the distributor will supply air on which, here's the bursting disc, and the distributor will open the starting air valve on the cylinder with the power stroke. So that's how it works. So the main starting valve is pneumatically controlled. Control air is admitted via connection A. So control air is admitted in here. As soon as the starting signal is over, the main starting valve closes. Starting air is vented through connection C, so it will vent here. In case slow turning is activated, the air in the main starting valve is vented through connection C. Air goes here. So for starting air distributor, the function is to distribute starting air to the individual cylinders when they are in the power stroke. So as soon as the main starting valve is opened, the control pistons are pressed against the cam. So these are the control pistons pressed against the cam. So the piston which is in the starting position will open, and control air is admitted to the starting valve in the particular cylinder. So if ever this one will go here, so it will give air. So this one is coupled to the crankshaft, or geared to the crankshaft. So if the engine moves, also the starting air distributor rotates. So the starting valve is operated by the air pressure coming from the starting air distributor. So air from the distributor will push open the valve spindle to allow starting air to enter the cylinder area. So there is air in here. Yeah, there's air in here. This one. But it cannot go inside the, so for example, this is the cylinder. Oops, there's a loading on my. So for example, there's a cylinder on the right side. So if the air is admitted into the this one, so the spring-loaded piston will go down, and then the air in here will open. So there's lag. Okay, let's continue. So the starting valve is operated by the air pressure coming from the starting air distributor. Air from the distributor will push open the valve spindle. So we're done with this. Flame arrestor. For flame arrestor, It prevents flame outbursts from the combustion area in case the starting valve in the cylinder head gets stuck in open position when the engine is started. So number 1 is the flame arrestor. This one is the flame arrestor. Number 2 is the cylinder head. This one. And the number 3 is starting air pipe. So if there is combustion in the cylinder head or there is flame outburst, so fire cannot enter back into our starting air pipe. Okay, for bursting disc located at end of starting air manifold. So in case of sudden overpressure in the manifold, the disc will break. The disc consists of a thin metal plate only. So it will break or will burst. So you cannot start again. So you should replace the burst first or find the fault and replace the bursting disc first, or the plate, thin metal plate, you can replace it afterwards. Okay, turning gear is used to turn engine before starting to check if no liquid is locked inside the cylinders. So the max number of revolutions for 2-stroke engine is 1 revolution, while for 4-stroke engine 2 revolutions. So you should turn the engine using the turning gear twice if you are having 4-stroke engine minimum, and for 2-stroke engine 1 revolution. So when turning gear is engaged, an interlock will prevent engine from starting. Okay, so if you engage it, that's the one, you engage it, that is disengage. So if the, yeah, that one, lock, engagement of the gear wheel with the activates as interlock. So there's an interlock in here, this one. So if it's engaged, so the interlock will be activated and the starting air cannot start. Okay, so that's how the turning gear moves. Okay, let's continue. So slow turning is automatic activated if the engine is stopped more than 30 minutes. So the goal is to rotate the engine at a lower speed to prevent any possible damage. So slow turning is completed when the engine has rotated through the configured number of revolutions in a predetermined amount of time. So usually 2 revolutions. So we also have stopping air system. So for stopping the air, we should activate the number 9 stop cylinder. So let's look for number 9. So this one. So let's go first with the auto stop 25. So this one is the auto stop. This one. Air is admitted in the high pressure filter and the receiver, and then in here, right? If you activate number 25, so the flow will go in here, entering in here, and then activating number 13. If number 13 is activated, the air inside here will go to the fuel pumps. So there are 2 fuel pumps for a V-type engine. So all the fuel pump in here will be given a signal to stop fuel supply to the engine. So if there will be no fuel supply in the engine will stop. So that's how it works. So starting world's biggest engine, you can look it up on YouTube. So that's it for today. Thank you for watching. Please do subscribe and help us share our contents to our other marine engineering students. Thank you so much.